experiment on horn antenna. So before we proceed, actually what we found, some of the roll numbers, some of the students are not submitting the lab records at all, as reported by Pushpa madam. So just it is a warning to you. I will call out the roll numbers. You know that who are the roll numbers who are not submitting. So you are required to perform the experiment today also. So it is a beneficial thing to you because you are performing the experiment in the lab itself. So it reduces your burden to prepare for the report because all the results you are obtaining here itself. Okay. I hope the screen is visible to everyone. Respond somebody?
Yes, sir.
Okay. So today's experiment is pyramidal horn antenna. And the basic thing about pyramidal horn antenna was already covered in the previous semester. Okay. So what we will do, just you can think of one thing, that a simple dipole antenna, two-wire transmission line. If you take a two-wire transmission line, whose open-ended two-wire transmission line, not shorted. Okay. So if you clear that two-wire transmission line, that will behave like a dipole. Now, recently you have been studying about waveguides, like rectangular waveguides in your microwave classes. So you can think of a waveguide section whose one end is open, and not only that is open, and that one is flared. Okay, so if a waveguide section, one end of the open-ended waveguide is flared, it will look like a horn, and hence the name is derived from its shape itself. It appears to be like a horn. That is why it is termed as horn antenna. Okay, so it has a very high directional radiation pattern. Specifically, these type of antennas are used at microwave frequencies. So you have to design a horn antenna like this and find its radiation pattern. So you can see the steps. Actually, some of the notable things I just wanted to say, that first of all you have to create a block. Let me show you. The final step, the final diagram is not shown, but all the steps are very well explained. I forgot to include that. Anyhow, all the steps are very well explained. So you have to create a horn antenna according to the dimension which is already provided in the manual. And like in the last class, you have to share your screen to get it verified. Okay, so follow each. Ask me. Okay, so your design problem of today's experiment is design a pyramidal horn antenna operating at 5.5 gigahertz. Take delta is equal to 0.17 and length of the horn L is equal to 160 mm. So what are these parameters? Let me go to the top. See, if you look into the cross section, the side view of the horn, you can see the L theta appears to be like this. So this delta is the, you can say, a path difference. Very small. It should be as less as possible. And the design equations are listed over here. And look into this, or you can find these design equations in any standard textbooks. And the design problem that I have taken is like this. I have taken delta to be is equal to 0.17 lambda. Lambda is the wavelength corresponding to the operating frequency, that is 5.5 gigahertz. and both E and H planes, for both E and H planes, and length of the horn is L is equal to 160 mm. Now, what is E and H plane? This is a general diagram. If you look at this horn from one side, then say it looks like this. And if you look the horn from the top, then also the figure will look like this. But in that case, your flare angle will be higher, right? So one plane is E plane. It is shown over here. If you look along this E plane, so that is E plane, and perpendicular to E plane, that is H plane. Okay. So in both the planes, all the parameters remain same. That is, theta is same, L is same, delta is same. And this is a pyramidal horn antenna. It is flared from both sides, both along E plane and H plane. That is why it is pyramidal horn antenna. Now, had the waveguide been flared only in one plane, that is only in E plane, it would have been called as E plane horn antenna. Or if the rectangular waveguide is flared along H plane, it would have been called as H plane horn antenna. So since it is flared in both the planes, it is pyramidal horn antenna. So the design equations are like this, and design problem I have given. So you can start your experiment. All the dimensions are calculated. You can verify yourself. Only thing you have to know is L. L is equal to A square by 8 delta, and in the design problem I have given delta to be 0.17 lambda, and according to that L, we get this A is equal to 110 mm. Okay, what is this A? Let us see. Aperture AE for E plane and AH for H plane. AE and AH. So both are same. AE and AH both are same in our problem. Okay. Since we are using the formula A square by 8 delta, and where we find that delta is same for both E and H plane, so it is so A will be same. AH and AE will be same. So after that, you can proceed as is given in the manual. Start the experiment. I hope you have received the manual. Somebody respond?
Yes, sir. Yes.
Yes, sir.